Hey guys, I'm Joe, and I've just recently finished my first playthrough of Elden Ring. It's an absolutely beautiful game with lots of great particle effects, but my favorite was the grace effect. And I thought it would be good practice to try and recreate the effect, so today I want to show you how to make it in Unity's visual effect graph. So first things first, we need to do a little bit of research to figure out what kind of particle systems we need to make. So the first thing I notice is that we have a head particle effect that sticks with the movement of the grace, and then we have a long wispy tail that at the beginning sticks with the movement of the grace, but over time loses its cohesion and trails off. We also have these rings coming out of the bottom, which look like a mesh particle to me, and it also looks procedural, so we're going to have to create a ring mesh. And then we have these trail and particle emitter systems that start far away and move in towards the grace. For the particles that we're going to have to create, I definitely see a star cluster particle, a smoke puff particle, some kind of noisy smoke particle, and a water caustic particle sticking out from the side. So on the trail effect, it looks like we have another water caustic texture. It's emitting stars as it flies, but we could probably use Unity's default particle for these. It also looks like we have a star flare effect, and it seems to be dropping leaves every so often. So now it's time to create our textures. So I like to use Krita, but you should be able to get the same effect in Photoshop if that's what you like to use. So now you're going to want to create a square canvas where the resolution is a power of 2. I use 2048 for this, and the reason for this is because this is the format that Unity expects textures to be in when it's importing, and it will make it easier for us in the future. I have the background set to black, and I'm painting with white because what we are creating are alphas, and alphas are textures used to determine transparency, where black is completely transparent and white is completely opaque. So I'm painting where I want smoke to be thick and leaving black where I don't want there to be any smoke. So let's start with the smoke puff particle, and for this you want to use some broad random brushstrokes to create some noise that's somewhat focused on the center of the canvas, and then using the smudge brush, blur the noise together and move the lighter areas around into a shape that looks like smoke to you. Next is the water caustic texture, and we're going to need the wrap mode for this, which is enabled using this button in Krita 5.0. We are using wrap mode to create a seamless texture, which will be helpful later. To create a water caustic effect, you want to start with some curvy wispy lines that connect randomly to each other with some broad gradients in the empty space in between the lines, using a blur and smear brush to smooth out these gradients and create a watery effect. Up next is the noisy smoke, which is a bit of a combination of the last two. We want to use wrap mode again to make it seamless and start painting random splotches all around and using the smear and blur brush again to create a tiled smoke effect. Now for the star cluster, this one's very simple, just some points of random light scattered around, mostly in a circle shape, using the blur brush on some to create a glow effect to create a cluster of stars. Now to create the wind trail effect, we need another particle similar to the water caustic particle, but less like water and more like wisps of smoke in random lightning patterns, with the blur and smudge brush to clean up the brush strokes. Now for the star flare particle, we can use Krita's mirror mode on both the vertical and horizontal to create a lens flare effect by painting a star shape and using the blur and smudge brush to smooth out the flare. And finally for the leaf, we just want to make a leaf shape with as much or as little detail as you want. Now it's time we open our new Unity project. Let's create a folder called Particles and import all our new images. Then let's lower their max resolution down to 1024 since 2048 is a bit of overkill for this system. Now let's create a new folder called VFX. Now let's right click, create, shader graph, VFX shader graph, and let's rename it Particles Shader. And then let's open this up. So the first thing we want to do is set up the ability for our shader to fade out near the edges, and we can do that using the UV node. The way we do this is that the UV node will give us a gradient of color in 3 directions, the X, Y, and Z, which are mapped to the red, green, and blue channels. For a 2D texture though, we only need to worry about the X and Y, which will be the left and right, and the up and down of our texture. And if we run the UV node through a split node, it will allow us to use these channels independently. Now we want to take our red channel and run it through a 1- node, which will invert the direction of the gradient, and then run that along with the original red channel into a multiply node, which will have the gradients fade to black on each side of the texture. And then repeat this process for our green channel to get our up and down gradient. Next, we want to run these both through their own multiply node, and then create a new float called edge fade distance. Set the default value to something like 6. Then drag our new float into the shader and plug it into the second slots of our multiply nodes. This will allow us to adjust how far the edges fade towards the center, with a higher value being a sharper fade. And then we want to multiply these two channels together. But first we're going to want to clamp this because we've gone way past the 0 through 1 that our alpha channel is going to expect. Next, we want to create a texture 2D, name it particle texture, drag it into our shader, and route it into a sample texture 2D. Then we want a tiling and offset node, route that into our UV. Then we want to create a new vector 2 called slide speed, and plug that into our offset. And this is going to allow us to control our scrolling in VFX graph. Now we just need to take one channel of our texture, run it through a multiply node, and then run our edge fade through the other channel. And this will allow us to fade the edges of our texture. But we need a texture to use, so let's find one of our particles. Go with the smoke particle. And then we need to create a boolean, so we can decide if we want to use the edge fade or not. So let's create a boolean, call it use edge fade. And then we need to route this boolean through a branch node. And a branch node will allow us to use one node group for true and a separate node group for false. And if we plug in the node group that has the edge fade in it to true and just the texture itself into the false, we can decide if we want to use edge fade or not. And now we need to create a gradient for our color. So let's call it color gradient. Rearrange it a little bit and pull it into our shader and send it through a sample gradient node. For the color of our gradient, I'm going to use one that I prepared earlier, and this is to just color our texture based on how transparent it is. Here are the values I used. We want to route our branch into the time to give us our color. And then plug this into the base color and the emission. Next, we need to make a new float called alpha, and this is going to allow us to control the overall transparency of our texture. Run this through a multiply node, and then run our branch into this multiply node and plug this into our alpha channel. And then we need to set the alpha to 1 as default so we can see anything, and then save our asset. Awesome, now that we've got our particle shader, we can create our first VFX asset, which will be the grace head. So let's right-click, create, Visual Effects, Visual Effect Graph, and let's rename it Grace Head. And then let's open it up. So the first system we want to make is a smoke puff, and the first thing we want to do is set the constant spawn rate down to something low like 2. We want to change our set velocity from random to off because we only want it going one direction and very slowly, so we want to make everything 0 except for y, which we want to make negative 0.4. We want to change the set lifetime to something like between 5 and 6 seconds, so 5 and 6. And then we want to add a set attribute size, random. And we want the random to be from uniform to per component, and we want the size to be between 0.1 and 0.3. Next we want a set angle, and we only want this in one axis, so we're going to set it to Z. And we want it to be random per component, and it's going to be negative 90 through 90 to give it a little bit of variance so it doesn't look too samey. Then we want to change the shader graph over to the one we just created. We don't need to worry about the edge fade distance because we're not going to be using it for this one. And we want to set the particle to the one we just created. Now we need to get rid of the set color over life because we don't need it. And then we need to change the set size over life to multiply, so we are modifying our original size and not changing it completely. Then let's make a curve that ramps up very quickly and fades out only slightly. So now we want our particle to fade in and out over its lifetime. In order to do that, we need to do this manually. So let's add an age over lifetime and plug it into a sample curve. Adjust the curve to something we want. We want it to first be completely transparent and then go all the way up to being completely visible, and then over time fade out to completely transparent again. And then because we want to use this curve for multiple particle systems, we need to run it through a multiply node so we can adjust the overall transparency of this particle system. And then plug that into the alpha. Now we can save our effect and take a look, but first we need to set up the grace. And to do that, first let's create an empty. Let's call it grace. Let's reset the transform so it's at world origin. Turn off the gizmos because they just kind of get in the way. Then in this we want to create another empty and just call it grace body. And then inside that, create another empty called grace head. And now we want to add our VFX graph to the grace head. Let's move the grace head a bit up off the ground and see what we have so far. Some smoke particles creating a head shape. Okay, let's pull this over to a new window so we can see what we're doing. Let's rename this to smoke. And then we're just going to duplicate this whole thing and just modify a few things so we don't have to do a bunch of extra work. Let's rename this to noisy smoke. We want to change the set size to something much smaller because this is just going to be a very small little effect. We want to get rid of the set angle because we don't want it rotated in any way. And then we want to add a set scale. And we want to set the Y to 1.8, and this will stretch it out downward a little bit. And then we want to put in a set position random per component to give it a little bit of variation of where it spawns. The number is going to be quite small because we don't want it going very far. We want to switch over to our noisy smoke particle that we created. We want to use edge fade for this. And then we want to add a set scale over lifetime, but only the X because this is going to make it, we're going to use this to squish it as it gets older. So we're going to start off at full scale and then over time just squish it down a little bit. And then let's change the edge fade down a little bit. And then let's give it its own multiply for its alpha. Actually, this is the same number, so let's just use this one. And then we want to drag our age over life out into a multiply. Make it -1. And plug this into the Y of our slide speed. And this will make it scroll a little bit as it lives. And then plug in the spawn of 2 particles because we're only going to need a few of these. And there we go. Now our next one's going to be much simpler because we're just going to change a few values of the noisy smoke we just made. So let's duplicate our noisy smoke. Change its name over to water caustic smoke. We're going to change the set size random to 0.05 and 0.1. Everything else should be the same. We need to change out our particle texture over to our caustic smoke one, our water caustic smoke one. We're going to take the scroll speed of our noisy smoke and plug it right into the same Y input. Then we're going to take the output curve into a new multiply because we want the alpha to be a little bit different. Change it to 0.2 and then plug this into the alpha. And then make sure we plug in our spawn system and save our VFX asset. And there we go. Next we want to give our grace a little bit of a glow, so let's duplicate our water caustic smoke. Change this to glow. This is just going to be another short modification. Change the set size to 0.25 and 0.3. It's going to be much bigger. Change the scale down to 1.5. We don't want it stretched out downward as much. And then in the set position random, we want to change everything to 0 except for -y down to -0.1. We want to change the particle texture to Unity's default particle, so in the search bar look for default and it should show up. And then we want to pull out from our sample curve into a new multiply node to give it its own alpha. Set this to 0.5 and then plug this into our alpha. And then plug the spawn system into the top. Hit save, and this is what we have. It has now got a bit of a glow to it. And now for the star cluster, we're going to duplicate again our glow system, rename it to star cluster or stars like I did, and then let's change the set size to 0.2 and 0.25. We don't need the set scale because we don't want it squished in any way, so let's get rid of that. And then let's change the set position, the Y of the set position to 0.5 and negative 0.5, 0.05 and 0.05. And then let's add an set angular velocity and set it to just the Z. Change it to random per component and set it to negative 15 and 15. And this is different than set angle because this is going to actually give it some spin as it falls down. Change our particle over to our star cluster particle. We don't need edge fade, so turn that off. And then we need to get rid of our set scale over life because again we don't want this being squished in any way. Let's just take the multiply from the alpha of our glow and add it to our stars. And then plug in our spawn system. Hit save and let's take a look. And here we go, we got nice clusters of stars falling down with our glow. Now we need to create the system that has the small individual stars coming out of the head, and this one is going to be a bigger modification, so first let's duplicate our stars system. Let's rename it to individual stars. We want to change the set velocity over to random per component because we want these to kind of be going out in every direction, not just straight down. Set all the values to 0.1 and negative 0.1. Then we need to change the set size to 0.01 and 0.04 to make them quite small. Change the set position random over to 0.05 for everything and then negative 0.05 for the opposite. We don't need to set the angular velocity, so let's get rid of it. And then we need to add a turbulence node to the update particle. And this will make it kind of just move around a little bit instead of just going straight out in a direction. Set the intensity to 0.2 and drag to 0.3. Change the particle texture over to that default particle that we used earlier. Just search for default and it should show up. And then we need an age over life into a sample curve because we want the alpha of this to be a little bit different than the ones we were using before. Let's plug this into a multiply node to control its overall alpha. Set it to 0.8. And then for this curve, it's going to be a little bit weird. We want it to start off as very transparent and then move to completely visible, but over its lifetime, we want it to flicker before it dies. So let's make the curve go up and down over its lifetime. Just like that. And then let's plug this into the alpha. And now we want a few more of these than just two, so let's duplicate the spawn system and set it to 4 per second, and then plug this into the top. And now we have our little stars that float out and kind of go all over the place. Awesome, now that we have our head set up, making the tail is going to be pretty easy. All we have to do is duplicate our head effect and modify the values a little bit to give our long wispy tail. So let's duplicate our head effect and rename it to tail, and then open it up. So the first thing we're going to want to do is change all of our particle systems over to world space. This will allow us to give us our wispy tail effect, but we don't want these spawning at world origin, so we need to make sure that all of our systems have a set position in them, and the set position is set to local. So in the first one, since we never set it, we need to add a set position and just set it to local and leave it at 0, 0, 0. And then on all of the other ones, we need to change it over to world space. And then we need to make sure that all of our set position nodes are set to local in all of our systems. So we just look at our set position and make sure this little bubble here says L. If it says L, that means local, and if it says W, that means world. Now we need to change the multiply size over life because we want our particles to shrink down to a tail shape. And to do this, all we need to do is change the graph so over towards the end of its life it shrinks down to 0. And now we just need to copy this curve and then paste it onto the curve of all of our other systems. Just not the individual star system because that doesn't need to change. And then for our noisy smoke and water caustic smoke systems, we need to change the set scale over life from X to X and Y. And then change the Y so that it starts off at 1 and then it scales really high up. We're going to set this to 3. Right click the node, set the value to 3, and this will make it stretch out downward very far over its lifetime. And then we need to do the same to our water caustic smoke system, and we just need to copy and paste our curve value to it. And then let's also add the same change to the glow system. Now we want the particle size of each of our systems to be a bit bigger than our heads, so let's go ahead and change all of these. The smoke we're going to change to 0.2 and 0.4. The noisy smoke we're going to change to 0.1 and 0.25. Water caustic we're going to change to 0.1 and 0.2. The glow we're going to change to 0.6 and 0.8. And then the stars we're going to change to 0.4 and 0.5. And the stars don't need to change, so no change there. And now I'm going to change the curve for our alpha so it takes a little bit longer to build up to full strength, and this will give us a little bit more of our tail wispy effect. Then we need to change the multiply for our scroll speed up to -3 so it scrolls a little bit faster. Then I want to change the multiply node of our water caustic smoke alpha up to 0.5 to give it a little bit more visibility. And then for the glow and stars effect we need a little bit of a different alpha curve, so let's set up a new age over lifetime and then plug it into a sample curve. And we're going to have a much sharper curve. It's going to go straight up to full transparency and then fade off very rapidly towards the end of its life. And then plug that into the multiply node. And then set the multiply down to 0.3. Now for the biggest change of this system is going to be the wispy tail effect, and this is why we changed all of our systems over to world space. To achieve the wispy tail effect, we're going to need a vector 3. This vector 3 is going to be the change in position that the head made from last frame to current frame, and we need to add this change in position to our particles. And over the particle's lifetime, reduce this effect so it seems to unstick from the head. So now we just need to add a vector 3. And then let's rename it something like trail velocity. Now, we need to set up the ability to update our particle position, and we can only do this in the update particle group, but we also want to put our set velocity in here as well, so let's remove the set velocity node that we have in each of the initialized particle groups. And then, in the update particle group, let's add in a set velocity, and then in the y, put it to -0.15, and then we want to add a add position. And this is how we're going to add the position of our particles from the movement of our grace head. Now, let's copy these two nodes and add them into each of our update particle groups. Okay, now for our script creation. Let's create a new folder called scripts. And then in here, let's create a new C# script, call it get velocity. And then let's open this up. Now the first thing we want to do at the very top is put in using unityengine.vfx so we have access to the VFX variables. And then above the class we want to put in square brackets execute in edit mode so we can see this happening in edit mode. Get rid of our start function because we don't need it. Now the first thing we're going to need is a vector 3 to hold the position that the grace head was in last frame. So let's put in a public vector 3 and call it old position. And then we're going to need a reference to our visual effect graph, so let's put in a public visual effect, grayscale. And then in the update, the first thing we want to do is get the change in position from our old frame to our new frame. So let's create a vector 3, let's call it trail velocity, equals this transform position minus our old position. This is the same thing as getting a vector, it's just we don't normalize it. Now we need to check if our grayscale is there so we don't throw an error, so let's do if grayscale equals null. Grayscale dot set vector 3. And then in brackets, let's put in quotations the name of our vector 3, which we called it trail velocity. So let's put in trail velocity. And then comma, trail velocity. And this will just set it to the trail velocity that we just found. And then we need to set old position to the current position at the end of our script to make it the old position the next time around. And that's it. Now let's add our grace tail effect to our grace. Let's create a new empty within grace body. Let's call it grace tail. To the grace tail, let's add our grace tail VFX graph. And then in grace body, let's add the get velocity script. And in our script, let's set the reference to the grayscale visual effect graph. And then let's reposition this a little bit to make it look correct. Now, if you move the Grace body around, you'll notice that the effect is not working yet, and that's because we haven't set up the trail velocity variable in our VFX graph, so let's reopen that real quick. Now, we want to pull the trail velocity out into the inspector and then plug it into a multiply node, and this is going to allow us to have it trail off over its lifetime. Then we want to take our age over lifetime and plug it through a new sample curve, and this one's going to be very simple. It's just going to start off at 1 and go down to 0. And then we want to plug this curve into the B input of our multiply. And then we want to plug this multiply into the add position of all of our update particles. And this will give us our wispy tail effect. Alright, for our floor effect, we're going to need a disk mesh, so let's create one in Blender. So let's open up Blender and right-click our default cube and hit X to get rid of it. Then let's hit Shift-A to go to our Add menu, go to Mesh and Circle. Then let's hit Tab to go into Edit mode, and hit A to make sure all of our vertices are selected on our circle. Hit E to extrude, and then right-click to let go. Then hit S to scale out, and this will give us our disk shape. Then let's go down to the timeline and click on the clock to open up the window menu. And then let's go to the UV editor window. Then let's go back to the 3D window and then hit 2 to go to edge mode and then select any of the edges that go from the center to the outer edge. Hit U and then hit mark seam to mark this edge as a seam. And then hit 3 to go to face select, select one of the faces and hit Ctrl L to select all of the faces. Now we're going to do a trick that allows us to get perfectly square UVs. So we're going to hit U and go to light map pack, and then we're going to go to U again and then hit follow active quads, and this will give us perfectly square UVs. In our UV window, hit B to go to box select mode, select all of our vertices, and then hit S to scale it down so it fits within our square. Then hit UV and check the Constraint to Image Bounds checkbox. Move our UVs down to the bottom left-hand corner next to where the 2D cursor is, and then hit period, and then go to 2D cursor to change the pivot point. Then hit S to scale this up to fill the entire UV square. And that's it. Now just save it as an FBX and we will use it later. Okay, so for the floor shader, it seemed like a procedural shader, so we're going to have to create a new one. So let's go over to our VFX folder. Let's right-click, Create, Shader Graph, VFX Shader Graph, and let's rename this to Floor Effect Shader. And then let's open this up. Now in this shader, we're also going to want the edge fade effect, so let's just copy it over from our particle shader. And then we need to change out this float that copied over into our own, so let's create a new float and call it edge fade distance again, and then plug it into our multiply nodes again. And set its default to 6. Now underneath here we're going to want to add in a Voronoi, so add in a Voronoi, and then set the cell density to 10. Then we're going to want to add a tiling and offset node, and then plug this into the UV of our Voronoi. Let's change the tiling to 1.25 and 0.7. And then let's add in a vector 2 called slide speed, just like the other one. And let's plug this into our offset. Now we want to brighten the white areas a little bit, so let's run our Voronoi into a multiply node and set the multiply to 1.5. Then run the multiply into a clamp node, and then the clamp node into a power node, and set the power to 5. This will widen out the dark areas a little bit. Now let's add a gradient noise node below our Voronoi nodes. Let's set the scale to 2. Then let's add in another tiling and offset node and plug it into the UV. Let's set the tiling to 2 and 1. Then run our slide speed through a multiply node and leave it at 2 because that's what we're going to use. And then plug this into the offset. Now let's run our gradient noise into a clamp, and then our clamp into a power. Set the power to 4.5, and then set the power into a multiply node and set the multiply to 3. Then run this into a multiply node to merge the two node groups together. Now let's create a new float, call it alpha. We're going to do the same thing we did in our other shader. Move this over and plug this into a multiply node, and then plug the alpha into the bottom of the multiply node. Set the alpha to 1 so we can see something. And then plug this alpha into the alpha channel. Run our edge fade node group into a multiply node, and then run the first multiply of our Voronoi area into the B. And then we need to create a color gradient, name it color gradient, and then use the same color gradient we used earlier. Pull that out, run it into a sample gradient node. Then plug this into the sample gradient. And then plug this into the base color and the emission. And because we probably want the shader to be working correctly, let's take the multiply node that has the edge fade in it and plug it into the alpha. Okay, now for the floor effect, we're going to need to make a new VFX asset, so let's go to our VFX folder, right-click, Create, Visual Effects, Visual Effect Graph, and let's name it Floor Effect. And let's open this up. Okay, so the first thing we want to do is change our constant spawn rate over to a periodic burst. Set the count to 1, and then set the delay mode to random, and then set the delay to 1.5 and 2.5. Get rid of the set velocity since we won't need it. We don't want this moving, we just want it growing. Set lifetime to 2 and 4. Now we need a set angle random node, and set its channel to just Y because that's the only one we need to change. Set it to 80 and negative 180 so we get some randomness in the way the particle is rotated. Then we need a set angular velocity random, and also set to Y. And let's set this to negative 10 and 10, so it will twist a little bit over its lifetime. And then we need a set size and set it to 0.3. Now we need to convert our output particle quad group into an output particle mesh. Change the shader graph to our floor effect shader. And now we need to import our disk mesh we made earlier. Open up our object and place its mesh into the mesh slot. Let's bump our edge fade distance up to 8. And now we're going to need an age over lifetime like before. Let's plug this into a multiply node. Set the B to negative 0.3, and then plug this into the X of our slide speed. Then we need to plug it into another sample curve. And for this curve I'm going to adjust it so it reaches about half transparency instead of full, because we're only going to be using this curve for this output. And then plug that into the alpha. We need to change our set size over to multiply. Then set the first node to 1, and then the second node up to something higher, like right around 1.7. And then get rid of the set color over life because we're not going to need it. And then get rid of the orient face camera plane because we want this facing straight up rather than straight at the camera. And then put in a orient fix axis and set the Y to 1. Now save our asset and let's apply this to our grace. Let's go to our grace empty and let's add a new empty. Create empty. Let's call it floor effect. And then let's apply our VFX graph to it. And here's our progress with the correct shader. Now for our grace trail effect, we need to add in a fun little system that Unity comes with called simple heads and trails. The system isn't going to be emitting any particles itself, we're just going to use it as the point that other particle systems emit particles from. And we need to modify it a little bit, so first thing we want to do is change the constant spawn rate to a periodic burst, set the delay mode to random, set the count to 1, and set the delay from 0.5 to 1.5. We need to remove the set velocity and set the color from gradient. And in our set lifetime, we want to turn random to off because we don't want this to be random, and set its lifetime to 4.5. And then we need to put in a set position shape arc circle, and this is how we're going to spawn these particles way away from the grace and have them move in towards the center. In the drop down of arc circle and transform, set its angles to 90 so it flips and is flat instead of up and down. And then let's set the radius to something really far like 35. Set the position mode to thickness absolute. Then we want to put in a set velocity from direction. Set the speed mode to random. Then we want the speed of the Y to be 0 and negative 10. And then put the minimum speed to negative 10 and max speed to 0. This will give the particle a little bit of a counterclockwise spin, kind of like how some of those particles have a bit of a curveball effect going towards the grace. If you wanted to go in both directions, just make the 0 a positive 10 and set the max to positive 10. And then we need to add an add velocity with nothing in it because we will be using this in just a second. Down in the update particle, let's get rid of the turbulence and then add in a linear drag set the drag coefficient to 0.5, and then put in another add velocity. Now we want this particle to move from where it spawns on the surface of the ring towards the grace, and to do this we're going to need a vector towards the grace. And the way we get a vector is we subtract the current position from where we want to go, the destination. So we need to put in a vector 3, and its destination is where the grace is. So x is 0, y is 1, and z is 0. And then we just got to subtract our current position. So we put in a get attribute position and set it to current, and then run both of these to a subtract node. Now this would move way too fast on its own, because this would set its velocity so it moves from where it is to the center of the grace in one frame. So we need to multiply this to a delta time node. This will make it where it would take the particle 1 second to get to the center of the grace rather than one frame. And then we want to run this to another multiply node set to 2, and put this into the original add velocity up in the initialized particle group, and this will give it a kick towards the center at the beginning so it doesn't have to speed up. And then we want to run this again to another multiply node set to 0.2, and then plug this into the add velocity of our update particle, and this will make it take about 5 or so seconds to get to the center of the grace. Now over in our trail system, in the initialized particle strip group, let's get rid of our inherit source color node, and that's all we need to change here. In the update particle strip, let's get rid of the turbulence. Down in the output particle strip quad group, let's put the shader graph to the particle shader that we created earlier. Let's change the particle over to our noise caustic smoke particle. And now we want to use the slide speed again, so let's add in an age over lifetime. Plug it into a multiply node, set the multiply to -1. And then let's plug this into the X. And then let's run this to a sample curve. Let's have the curve ramp up to about 0.5 and then fade out. And then let's run this into a multiply. And let's set the multiply to 0.1. And then plug this into the alpha. In our set size over life, let's have it ramp up to about 0.4 fairly quickly and sort of hold that position for a bit before fading out in the last quarter of its lifetime. And then let's save our asset and see what we got. We now have a little holy golden wind effect going towards the grace. Okay, back in our floor effect graph, we are going to create the star system for our trails, and this is going to work very similarly to the trail system, which is to use a trigger event rate over time in the update particle group. We're going to create a new one, set its rate to 15, and then we need to duplicate a GPU event and plug our new trigger event rate into this new GPU event. And then underneath this, we're going to add in a simple particle system. We need to get rid of the spawn system that comes with this, and then attach our GPU event into the top of the initialized particle group. Let's change the name of our particle blocks to something appropriate. Down in the initialized particle group, let's change the add velocity over to random per component, and then let's change the set lifetime to not random. And then let's change the lifetime to something larger like 5. Let's put in an inherit source position and velocity, and then put them up near the top. This is what causes our particles to spawn with our trails, and the velocity gives them the same speed as our trails. Let's put in a multiply velocity and set them all to 0.3, and this is to lower the velocity that it starts with, because otherwise it will be moving way too fast. Down in our add velocity random, let's change everything to be between -1 and 1, except for y. We want y to be between 0 and 1, because we want these particles to be mostly moving up to get the right effect. Let's add in a set size random, and let's change it over to random per component, and then let's set the size to be between 0.1 and 0.15. Down in the update particle, let's add in a turbulence node and set the intensity to 0.3, and this is going to make our particles wiggle around a little bit as they live. In our output particle, let's change our shader graph over to our particle shader. Let's take our age over lifetime node and run it into a new sample curve, and then in this curve we're going to do like we did in our other particle effect for the flicker effect, where it ramps up in intensity and then it goes up and down to give our flicker effect. And then plug this into the alpha. We need to switch our particle texture over to the correct default particle texture, which is the default hyphen particle, which is not confusing at all. And then we need to set our capacity up to something much higher, to like 256, because there's going to be a lot of these particles. Now we need to get rid of the set color over life, then change our set size over life to multiply, and then change our curve over to something that's kind of like a hill shape. And then let's see what we got. We now have our nice faint stars coming out of our trails. Now for our star flare system, let's do like we did for our stars, and let's put in a new trigger event rate over time. Set it to something low, like 3, because we don't need a lot of these. And then let's duplicate our GPU event and plug it into our new duplicated GPU event. For this, let's just duplicate our star system, then rename it to star flares. Let's bring the capacity down to 128 because we're not going to need a ton of these. Down in the add velocity, let's change our Y to be between -1 and 1 because we don't want these all floating up like our stars. Let's change the set lifetime to be random per component and set it to between 0.5 and 1. Then let's change our set size random to 0.5 and 1. In the update particle group, let's put in a linear drag and don't change any settings. We just want this to kind of make these stars trail off instead of keeping up with the trail. Down in our output particle, we need to change our particle texture over to our star flare particle. And then we need to change our multiply size over life to be a sort of very sharp hill. It starts off growing very slowly, then suddenly shoots way up, then way down again, and then fades off very gently. This is to give it that kind of pop effect. We also need to plug in our GPU event if we want to see anything. And now we have our flashing stars, but first let's plug in our alpha curve so they actually fade in and out. And let's adjust our curve a little bit so they don't get quite as big. And now we have our flashing stars. And now for the leaf effect, let's repeat what we did before. Let's create another trigger event rate over time. Let's set it to 1 because we're only going to want 1 leaf at a time. And then let's hook this up to another GPU event. Let's duplicate our stars block and then rename it leaves. And then like before, let's change our add velocity Y to be between -1 and 1 again, because we want these to be going up and down as well. Let's change our set lifetime to be random per component, and then let's set it to 2 and 4. And then in the set size, let's set it to 0.2 and 0.3. Then let's add in a set angular velocity, switch it to random per component, and then set them all to between -40 and 40, and this will cause our leaf to tumble over its lifetime. We want to keep our turbulence, so no change there. Down in the output particle, let's change our particle texture over to our leaf particle. Let's add in an age over lifetime node, and then plug that into a sample curve. We want this to go up to something like 0.3, and then fade out. And then plug this into our alpha. And then let's change our multiply size over life so the leaf stays at full size for a little bit before fading out. And then we just need to plug in our GPU event at the top. And now we have our leaves that spawn and seem to flutter in the wind for a second before fading out. Over in the main system, you can increase the lifetime a little bit to have these trails get closer to the grace before they fade out. And the capacity for our main system is a little high. The number of particles it spawns is the number of trails that are going to be spawning. And let's set it down to something like 4 so we don't have this overcrowded with too many trails. And now, all that there's left to do is to give it a light so it has a glow effect. Let's put in a floor so it has something to sit on. Let's change up the sun so it's nice and dark in here so our effect really pops. Adjust our light so it has the effect we want. And then we just need to do a little bit of animation to give our wiggle back and forth effect. Well, if you made it to the end of this very long video, thank you so much for watching. If you have any questions, please give me a comment and I'll try and get those answered. If you learned anything from this video, please consider dropping a like, because those really help. And if you want to see more videos from me in the future, please hit the subscribe button. The next few videos I do are probably going to be much shorter ones, just little tips for Unity. And from there, I'm not sure. But if you enjoyed this, thank you for watching, and I'll see you next time.